Hey guys, this is Ms. Gephardt, and we're going to go through the chemistry study guide, so hopefully you all have that. We're just going to kind of go through the answers. This is going to probably be broken up into a couple videos, so just be prepared to go to other videos as you're going through the study guide. Okay, the very first question from the study guide was asking about the different forms of matter and how each of those forms of matter kind of comparing them. So in doing that, I just made a chart. Thought it would be easiest to see it that way. So we look at solid. We know it's got a definite shape and volume. We know it doesn't take the shape of its container. We can demonstrate that. Here's a cup. Okay. Here's my son's DS, and it's a solid. I can push it. I mean, I can do this, but it's not taking the shape of the container. Okay, this is going to it's going to remain in the shape that it's in. All right, a liquid, if I poured it inside of here, it would take the shape of this container. Okay, that's the difference. Between the solid and the liquid, the particles are further apart. Liquids have a definite volume but no definite shape. Gases have no definite shape or volume, but they definitely will, if I fill this up with a gas, it will take the shape of this container. You guys saw that when we did the baking soda and vinegar, and it filled the bag up in the classroom. It was kind of like a balloon. So think of like a balloon too. It fills it up and fills the shape of that container. All right, number two was kind of looking at the looking at the different. Sorry, my dog's kind of going crazy too. Looking at the different ways that matter can change state. So this is the diagram you guys had in notes. So just make sure that you have these notes and that you look back at them, but just kind of keep in mind how the arrows flow. The biggest thing to see is, just be knowing the terms. Like we see condensation and vaporization and melting and freezing. The blue arrows tell us a release of energy, and the red ones are telling an absorption of energy. All right, the third question on this was focused on just the general structure of an atom. So that's why you just kind of drawing it out. This is important right here. So electrons are green, a negative charge. Protons are blue with a positive charge, and the neutrons are that red. They have no charge at all. Remember this inside right here, that whole thing, that makes up the nucleus. And we know that all of this out here is and I don't have enough room to write it, but the electron cloud, and it surrounds the nucleus. Okay, the next piece was a comparing of the atomic number and atomic mass. So atomic number is the number of protons in an element, and this identifies that element. So if I go to a periodic table, that's if I have 2 or if I have 4, if I have 6, if I have 8, it tells me specifically what the atom or the element I'm talking about is. So atomic number is the number of protons. Atomic mass is going to be the number of protons plus the neutrons that are in the entire nucleus. So we're looking at the whole entire nucleus. That's the mass. The number is just the proton portion. All right, the next question, you had to look at the periodic table, and this is just getting more practice, making sure that we understand how to use that element key. Okay, but here's our element key, and we have, carbon. The number at the top is going to be my atomic number. The number at the bottom is my mass. So we go through, you had to look at the periodic table, fill this kind of chart in. When we calculate our neutrons, okay, when we calculate this guy right here, remember that we have to take mass and subtract it from the atomic number. Okay, and that will equal neutron. All right, and so that's how I got these. So if you take 6 and you take 12 and you take 12 minus 6, you're going to get 6. If I take this 107.9 and I round it to 108 and subtract it from 47, I'm going to get 61. So you kind of get the hint there. All right, sorry, I jumped on. The next question was just kind of a fill in the blank. So a column on a periodic table is called a group. The group or the family, and it goes up and down. So the column goes up and down. A row, which goes left to right, is called a period. Okay, so just know those basic terms. All right, number 7 is focused on the definition of metals. All right, so metals are on the left side of the staircase. So I'm actually going to come out real quick. I'm going to go to the periodic table. So if we look at this periodic table, the left side of this periodic table, okay, that's all of these elements, you know, on this left side, which is kind of hard to see, but the pinkishy color, the yellowy ones, the orange one to the left, that's the metals. And these guys are going to be defined by the fact that they're malleable, they're ductile, they're very good conductors of electricity and conduction of heat. So when we think about a stovetop, we put metal pots on it. If we think about malleability, you bend aluminum foil. Okay, so those are all characteristics that define a metal. We think about a non-metal, okay, they are kind of everything that's opposite to that of a metal. Back to that periodic table, all right, we're looking over to this right side where this blue is and this kind of seafoamy green and this neon-ish green kind of colors. Those are all of our non-metals. You can also see it's labeled on this thing as well. And in terms of your test, you're going to be given a periodic table. You're just going to make sure you have to know the left side of the table is the metals, the right side is the non-metals, and along the staircase are the metalloids. So everything characteristic for a non-metal is going to be opposite that of a metal. Dull, not malleable, not ductile. They're not conducting electricity, and they're not going to conduct heat. That's kind of what just defines the non-metal. A metalloid shares both characteristics, okay? So remember, these are going to be things that are going to be able to conduct electricity really well, but they're not going to conduct heat so much so that they catch fire or something like that. So think about even what I'm on right now, my nice little, bend it down, my nice little laptop. It's able to conduct and it will get warm, but it's not going to get so hot because it's not pure metal. It's going to be this metalloid that's going to kind of have the best of both worlds. And the example, or the metalloids that are on the table are listed here. So B, G, E, S, I, A, S, S, P, T, E, and P, O. All right. Number 10 had another bit of fill in the blank. So it's just identifying and labeling those different families or groups. Group 1, these are the alkali metals. Okay. Very, very reactive. The most reactive metals on the table. Group 2 is known as the alkaline earth metals. They're still reactive, but not quite as reactive as the group 1s. The group 3 to 12, these are our transition metals. Group 17 is known as the halogens. They're reactive non-metals. So they're the most reactive non-metal. Okay, remember that. Group 18 are called the noble gases, or they're inert gases, and they're not going to react at all because they're very content and happy. They have full valence electron shells. They're happy, content. They are not seeking out anything else. Okay, number 11 was dealing with mass, density, and size, the trends on the table. So as we look at the mass is going to increase from the left side of the table to the right side of the table. And then as we go from the top to the bottom. So if we were to find the greatest mass, we're going to be shooting for that bottom right corner. Okay. The largest element would be, or if we think about element size, it's going to be increasing as we go from the right to the left, and as we go from the top to the bottom. And the largest sized element is going to be at the bottom left. Okay. Density is going to be actually coming inward towards the center of the table. So you're looking at towards the bottom middle of the table is going to be where we find our densest element. All right. Number 12 wanted to know what valence electrons were, and then using the information, creating Bohr diagrams. So the valence electrons are the number of electrons in the outer shell or circle. And we can determine that by looking at the group numbers. So remember, when we numbered them in class, we went 1, group 2, we skipped all of the transitions, and we started at 3, actually at number 13. So when we renumbered them, we went 1 and 2, we skipped all the transitions. 13 actually became 3, so 14 became 4, and so on. So we went 1 through 8, okay? And that's the number. So whatever group they're in that area, that tells us how many. And as you can see, I went through and did them. So we have carbon, we have fluorine, which I'll bring that down a little bit, fluorine, neon, and magnesium. Okay, so remember the period number tells us how many circles that we need to draw. And the group number tells us the number of electrons in the outer, this is the outer circle, that's the outside circle. Okay, so that is the group number. And the period number told me how many of these I needed to draw. 1, 2, 3. Okay. Question 13 asks, what are ions? So an ion is an element that's going to want to gain or lose electrons. Okay. The positive ions want to get rid of an electron. Okay. And these are going to be found in groups 1, 2, 13, and 14. They're going to want to get rid of it. So remember, we want to think of sodium, okay? If I had sodium and I draw out sodium, all right, its outer circle, which this isn't the perfect drawing, but its outer circle actually just has 1 electron sitting there. So this is a positive ion. If it could get rid of that electron, it would be a very happy camper. The other type that we have are called negative electrons, or no, I'm sorry, negative ions. Negative ions want to gain electrons. So when I'm thinking about that, there's something like chlorine, okay, and its outer shell is going to have 7 electrons. So chlorine would be a very, very happy element if it could find 1 more electron. That's why it's negative. It's seeking it out. Okay, it's negative. It wants that 1 more. Okay, we're going to find this in 14, 15, 16, and 17. They're going to tend to be our negative ions. Okay. Number 14 says, write the name of the following chemical formulas. So MgCl2, Mg is magnesium, and then of course our Cl is chlorine, but because it's a compound now, we have to remember we have to change that ending to an IDE. So it becomes magnesium chloride. LiBr now is lithium bromide. Al2O3 is aluminum oxide. And BeBr2 is beryllium bromide. So in all of these examples, we've changed that ending. Okay, when we write them out, we write them in the order that it's written. So this is written first, this is written second. First, second, first, second, first, second. Remember, think of it kind of like marriage. They got married, so this person here had to change their name. Okay. I'm going to stop for this video right now. And if you'll please make sure you go to the second video to get the remaining questions.